Over the years on the channel, you may have noticed I posted a couple of videos that display a random maze on the screen, which was procedurally or randomly generated. I've thought about it, but I never really knew how do you go about creating a program that actually solves the maze. And that's what I wanted to discuss in this video. My interest was piqued when the recent Numberphile video came out called the Lightning Algorithm. And Brady brings in a gentleman named Matt Henderson, and they talk about him generating this lightning in mazes. It's not really lightning, but the solution sort of resembles lightning. And he's doing this using the algorithm called breadth first search. And that algorithm, as I understand, it will look through a maze and it will find the shortest path to complete that maze. And as I was researching, I found there are many different algorithms for maze solving, and a fairly simple one to implement is called depth first search, DFS. This method will solve a maze, but it won't necessarily be the shortest path. And while I was researching the topic, I came across a really neat assembly language program on the Lemon 64 forum, and it was posted by Aart Bik. And what it does is it has a minus sign for the starting location on the maze and then a plus sign for the finish location. What you can do is you can go into his program code and just move the minus sign and plus signs around and run the program and check it out. And I thought that was really neat. What I wanted to do in this video was sort of go ahead and download his program and then dissect it a little and see what we can do with it. Alright, so the first thing we're going to do is go over to the Lemon 64 website, and we can be mesmerized just watching it. So this is his program actually running and solving his maze, and then this is the code. So what we're going to do is copy his code and bring it in and convert it to Kick Assembler. So I'm going to create a new folder. And we'll call it maze solve or something like that. And we'll do a new file, maze1.asm, Control A, and paste that in. And then the first thing we're going to do is convert the comments into the proper notation. So we're going to go up here to File, Find, Replace. Every semicolon, we're going to switch it to 2 forward slashes. And replace all. The next problem that we have, we need to probably do this as a basic upstart right here. So we'll strip this out and do basic upstart to main, just to make the program look a little more readable. And then all the labels we'll have to change. We'll have to add a colon to them. These need equal signs instead of EQU. And then the labels here need colons on them. We'll try first compile. Oh, yeah, we have to put dot labels on all these. And then on this last one here where it has the comma 0, Control H. Find dot byte and replace it with dot text. Do all. Except for this last one, we're going to switch it to dot byte. And see if we can compile this. And it does. It's running right now. So there it is. Found the solution. You can see the minus is right here and the plus is down here on the bottom right. So that is the demonstration of the program, and we can take a quick look at it. You'll see here the first part of it just generates a maze. It's not generating it, it's displaying a hard-coded maze. What we can do is we can move around the destinations. We can move this plus to say like right here, and then rerun it, and you can see if it will find a solution for the new location of the plus sign. Very quick, it just went right there. And then when it backtracks, it puts dots. You'll see it puts the dots there instead. So one of the things I was trying was like just put a wall right here and then open up something right here and see how that changes it. Oh, and then maybe block this one right there. Just kind of make it difficult for the maze to try to solve to see if it adapts. And then in this case, there's no solution because it can't get across the way. So you kind of have to open something up. So maybe open up this space right here and try it again and see if it can solve the maze. Oh, directly solved it very fast. We open up something down here. That might be a little trickier. Boom, went right to it. So it's a really neat program, and it uses the DFS algorithm and with backtracking. And that's what these dots are. So every time it had to backtrack, it places a dot instead of the asterisk. The asterisk, of course, is the solution. All right, so taking a quick look at the program code, you'll see this is a recursive backtracking algorithm. And what you'll see here is when the program does go east or go south, when it chooses a direction, it changes a pointer on the screen low and the screen high. It increments it. If you're going east, would be to go right. And so it increments it by 1, checks the high byte if it needs to be incremented. And then it recursively calls the search algorithm again. And then once it returns back from that search algorithm, that means that it can no longer go in that direction and it couldn't go east any further. So then it returns to this spot and it undoes the go east. It makes it go the opposite direction by doing a decrease, the screen low and the screen high. And but what I was found when I was looking through this was that it's a little confusing to read. And so what I've done is I went ahead and reformatted the code a little bit just for me, and nothing against the original author or anything. So let's go ahead and take a look at that. So we're going to do a new file. And we'll call this one maze 2. And I'm going to bring that in and show you what I did. So where there were these cases where there was like an addition, it does this, add 40. All of this, a little more readable if you throw it in a macro. And so that's what I did. I created these macros down here at the bottom. So for move east, you have increment the low byte, and then if needed, increment the high byte. Move west, similar sort of thing. And then for move south, we do add 40 to the low byte of the screen pointer and adjust the high byte as necessary if there's anything in the carry. And then the same thing with move north. And then what that did was it allowed me to look at the code a little easier to see, okay, so move east, then call your search algorithm, then move west, then check to see if the maze is solved. If not, go to the next direction. So this one goes in, it goes east, then it goes south, then it goes west, and then it goes north. When you do the subroutine to search itself, it moves east, 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 east until it can no longer move east. Then it goes, oh, move west to undo that last move. Then we're going to go another direction. And so it checks to see is the maze solved? No, go south. And then you go south, south, south until you can no longer go south. That's what the subroutine JSR, it's a recursive call to itself. And search is up here. Search, all it's doing is saying, go ahead and load in the character that's behind the pointer. Check to see if it's the plus sign. Plus sign means that you solved the maze. So if it's not, check to see if we're on a space that we can move to, which is a space. And if not, then return back. And then if it is a plus sign, we come over here and we set the flag for maze solved. If it's a space, if it is a space and you can move there, then it goes down here to mark visit. And all that does is put an asterisk. So it loads an asterisk and stores it in that position, stores it at that pointer. And then it comes down and does the delay. It does a little delay. You need that delay, otherwise it just, boom, spits it out and completes immediately. And then it continues in to go east. Now, when there is no place to move to, after you've gone north, east, south, west, if you can't go any of those directions, then there's a dead end. When there's a dead end, the program puts a period at that location. So it's a little bit confusing, but it throws the period there and then it returns back. It does an RTS. And basically that will pop off the stack and go to the next direction. And it's a little confusing because it's recursion. But I encourage you to go ahead and take a look at this source code. I'm going to put it on my GitHub. And just kind of maybe step through it in the debugger. Now, one of the things, let's run it. Now, one of the things to note that this is a backtracking algorithm. Every time this dot moves, it's doing a recursive call to itself to search the next spot. And so as it goes, it's taking up more and more of the stack. And on the Commodore 64, it only has 256 bytes for the stack. If the maze is large enough, or if it can't solve it soon enough, then the program will crash. And I want to show you that by showing a broken maze. So I'm going to comment out the current maze, and I'm going to comment in the broken maze that I tweaked around with just to show you. We'll hit F7 to run that. So this maze right here is solvable, but the stack runs out of memory and it just crashes. And that was discussed on the Lemon 64 forums. You know, like what happens if your maze is too large, or if it can't solve it soon enough. And at first, Aart said, hey, you know, all you have to do is build your own stack. You know, don't use the built-in stack. And I'll leave that as a exercise for the student, or for the people that read this forum, which is cool. But then a few posts later, I don't know how many days had transpired, but just a few days later, he posted another version. It's also on his website, which he put in his comments right here. And he posts the source. And this version swaps out the stack. So wherever you do the JSR search, you swap it with JSR do JSR. And then wherever you do an RTS, you swap it out with a jump, do RTS. And all this is doing is when it gets here, it's pulling a byte off of the stack, the low byte, and then it's storing that byte. It's storing that byte into another location in memory. And I think he set aside C000 for that. And then he has a little stack pointer, the stack length here that he increments, and then he pulls the second byte off and puts it in the second byte position. And then when it does the RTS, it pulls from that location in memory as opposed to, so basically he manually built his own little stack right here. And so I have pulled that in. Let's create a new program, file, new file, maze3.asm. Let's do Control S. We'll save that. Control A, paste in. So what I went ahead and did was I pasted that version of the source code in that we were just looking at. And I changed the, where it said JSR search, I changed it to JSR do JSR. And now we're looking at the same maze right here, and we'll run it again. That maze was solvable, but in the other program, it would crash because it didn't have enough stack space. On the Lemon 64 site, he does list a few, he does show a few samples right here of different mazes, and just showing that, hey, now any size maze that you make without scrolling, of course, just it's on one screen, it can solve without crashing, at least. I did try my hand at trying to figure out how to do a depth first search algorithm, and I did a little pseudocode here. But this type of program is not very easy to develop. It's in a assembly language. It's much easier to do in a high level language. But essentially, you have a loop. You're in an endless loop here until you exit the sub. But you check all the directions. Can you move up, down, left, and right? If it's a dead end, then we exit the sub. Otherwise, we mark the current spot as visited. Can we move east? If we can, move east. Otherwise, can we move south? If you can, move south. Otherwise, move west. Otherwise, check to see if we can move north. And then it calls itself again. So that was the idea here. I didn't really implement this, but because once I found Aart's program, it's brilliantly put together and it's really neat. I wanted to share that with everyone here. There's one more thing I wanted to try, and let's take a look at that now. So let's go ahead and do a maze 4, file, new file, maze 4.asm, Control S. And let's paste in from maze 3. So what I want to do in this version of the program was I wanted to marry together the maze generation that I did in Amazing Race and also in my maze video that I showed, and then have it generate a maze and then have it solve rather than using a static maze that we have here. Let's get started on that. All right, so what I've done is I went ahead and I extracted the maze generating code out of my last project, which was the Amazing Race project. What it does is basically just draws a maze. Let me see if we can run it straight out like this. Of course not. 8192. And it draws it kind of slow because I was trying to conserve memory at the expense of performance. But it does generate a random maze, and you can adjust the width and height up to this size right here before you start having problems. But what I thought we could do is put the start right here, the minus sign, and then the plus down here in the corner. And then just have it randomly generate the maze. So let's try that. What I wanted to do is go ahead and bring it into this one. So this is the program earlier. Right now the program draws its own maze and solves it. And what we want to do is strip that maze out eventually and only use our new maze generator. So what I want to do is here at the bottom of the program, I'm going to import the maze generate program there at the bottom. And at the top, just to see if it works, we'll do a JSR. And then we'll just do this. And the JSR is to draw the random maze. And run that. So now we should just get the maze I showed you a second ago. Now all we have to do is put the minus somewhere in the maze and the plus somewhere in the maze. I'm going to use these two corners. And I've already mapped them out. So I'm going to do LDA dash store it at 429 as the top left, and then load a plus and store it at 7BD. Let's make sure I got those coordinates correct. Yeah, so we got the minus and the plus. Now let's go ahead and strip out what we don't need. So what I think we could do is comment out what we don't need so it doesn't generate the second maze or the initial maze. And I believe that piece of code is right here. I'm not sure if we need that LDY. I'm tempted to leave that in. Comment that out. Okay, yeah, there's an LDY 0 there, so shouldn't need this. These are just variable initializations, and we don't need this maze up here anymore. And let's see if this works. Let's see, right? That should work. Let's F7, let's try it the first time. Hey. And then what we could do is implement where you hit the space bar or just have it just keep repeating. Let's do just the repeating part. So let's come here. I guess we can make this a sub. Let's see how we're going to do this. Let's make this begin. And then here we'll go begin, JSR main, jump to begin. And it's just going to endlessly run this. Oops, got to be lowercase. Because the maze is different every time, you'll get different results. I think I would like it to delay to like a space bar so you could check it out. Or press any key or something. See if there's any that it can't solve. Looks like it, oh, it's gonna zoom back. Yep, got it. So it clears it so fast you don't even have a chance to appreciate it. Let's try to implement an any key press type of thing. And I think that we can do that with loading C5 in. Maybe do this. Might have to check what that is. I think C5 is a character buffer. Stuck right there. Let's see what it's stuck on. Break in here. And Shift F7 to run the debugger. So after it solves, we should hit our break. So it's loading C5, F10. It says it's the accumulator is 40. Okay, so let's do comparison not equal to 40. And as long as it's equal, then we'll loop right here. We'll see if that does it. I don't know. Oops, F7. Oh, got my break in there still. Darn it. Space. Hey, there we go. Press anything, basically. So it didn't have to do a lot of backtracking there. Ooh, yeah, that one did a lot of backtracking. So anyway, we could keep running this forever. I'm gonna post the source code up on my GitHub. I'll put all versions here that we looked at today, the maze 1, maze 2, maze 3, maze 4, and the maze generate. Just know that this generate may not be perfect, but it works well enough for most testing that I do. I was really impressed by Aart Bik's algorithm, and go check out his website, and you can download this source code directly there, and I'll put all the links in the description, and thanks for watching. I appreciate it.